Hello viewers, today in this video we are going to study about crystal defects, which is a part of the chapter solid in chemistry class 12th. Before I start, let me request you that you please subscribe my channel and uh, see the video till the end so that nothing important is left. Now let me start the class, and the topic of the class is crystal defects in crystals. See, the crystals are not perfect. There are some defects, there are some impurities, imperfections in crystalline solids, and they are of four types, namely point defect, line defect, surface defects, and volume defects. In this lecture, we shall concentrate only on point defects. See, point defects in crystals. How it arises? How? During the process of crystallization, whether it is a slow rate crystallization or fast rate crystallization, what happens? Some of the irregularities develop as point defects in the crystals. Some vacancies are created, some additional particles are positioned are positioned in the crystal lattice, and according to that we classify these defects. And classification of defects. See, these defects are having advantages. कुछ इनके फ़ायदे भी होते हैं और कुछ नुकसान भी होते हैं. That we will discuss in our video. See, there are classification of defects. One is for non-ionic solids. Second is for ionic solids. And then for metals, and then impurities. Broadly speaking, these four type of defects are there in crystalline solids. In non-ionic solids, see, there is one vacancy defect, and the other is interstitial defect. In non-ionic solids, non-ionic solids means in covalent solids and in molecular solids, like in quartz, in diamond. So in these non-ionic solids we find this vacancy defect and interstitial defects. And in ionic solids there is one defect, Frenkel defect. Other is Schottky defect. These are in ionic solids. And in metals, one is metal excess defect, and other is metal deficiency defect. And then the fourth type is impurities. So first type of defect is for non-ionic solids, then second for ionic solids, and third for metals, and then impurities which are found in every type of crystals. So we will study one by one. First we take non-ionic solids which are found in non-ionic solids, and that is vacancy defect and interstitial defect. This is for non-ionic solids. Non-ionic crystal solids. What happens? One is vacancy defect and other is interstitial defect. In vacancy defect, what happens? Some of the lattice sites are vacant. Why they are vacant? Because during the process of crystallization, the particles, the atoms which were to be present at that site, they are missing. They don't they are not present at that site. वो उस site से missing है, so that the vacancy defect arises. See, this is the diagram. This is the broad diagram, not actual, but it is for explanation. We have taken these. This is the particles, atoms which are arranged in the crystals, but these are the sites where the particles, constituent particles, are missing. So these are the vacancies. So the particles are missing from their sites, and in that case the density of the solid decreases due to this vacancy defect. And the second is, in non-ionic solids, interstitial defect. Interstitial defect, what happens? When some of atoms or molecules, whatever the constituent particle, they occupy the interstitial space. See, in this example, the particles are arranged in the crystal, but these particles, they have occupied a space between which is called interstitial, between the constituent particles. These are particles, interstitial particles. So due to presence of these interstitial particles, interstitial defect has taken place, and due to this defect, the density of solid increases. Density of the solid increases. So this is the defect in non-ionic solids, and like in quartz and diamond and other molecular solids. Now we come on to the second type of defects, which is in ionic solids, and that is Frenkel and Schottky defect. See, in Frenkel defect, what happens? Frenkel defect, what happens? Smaller ions, because these are ionic solids, and ionic solids are the crystal solids which are the constituent particles are ions, like in NaCl, Na plus and Cl minus, they form the constituent particles, and so on. In KCl, potassium chloride, potassium and Cl, these are the constituent particles. So in ionic solids, ions are the constituent particles. Like this is cation, this is anion, this is cation, anion, cation, anion, and they are arranged in the crystal in regular manner. But what happens in Frenkel defect? The smaller ions that are cation, they are dislocated from their normal site. ठीक है, dislocated from normal site and leaving behind the vacancy. Vacancy is created. Vacancy is created where they are at the original site of the missing cations. Vacancy is created at their place, and they occupy a place in interstitial space. Means here a cation is missing, here a cation is missing, and these cations are located at a different place, interstitial place. Then what happens? Number of cations, vacancy is created, and cation is placed at a interstitial space, so that cation and anion, they are equal. Number of cations is equal to number of anions, and electrical neutrality is maintained, because number of cations is equal to number of anions. The number of cations which are missing, they have been placed at a interstitial space. And what happens in Schottky defect? Schottky defects, that ions and anions, here it was plus cation, and here it was minus, here it was anion, and here it was also anion, and these three anions are missing. Then this cation also missing, and this cation also missing. See, 3 anion and 3 cations are missing. 3 anions and 3 cations. The missing anions and cations are equal in number in Schottky defect, so that electrical neutrality is maintained. Electrically neutral. This is maintained because number of positive ions missing is equal to number of negative ions. So the crystal solid remains electrically neutral. Now we will discuss the difference between Frenkel defect and Schottky defect. See, let me tell you one interesting thing, that is that vacancy defect is analogous to the vacancy defect in non-ionic solid is analogous to the Schottky defect in ionic solids, and interstitial defect is analogous to the Frenkel defect in ionic solids. Now we see what is the difference between Frenkel defect and Schottky defect. Point wise, what is the difference between the two? So the smaller ions that are cations, they are missing. They are dislocated from their original site and positioned at a interstitial space, and here cations means positive ions and anions are missing equal in number. Now this is also electrical neutral. This is also electrical neutral. These are the substances. The Frenkel defect is shown in the substances which have low coordination number, and Schottky defect is present mainly in the substance where high coordination number. Now due to this Frenkel defect, density is not changed, because the ions which are dislocated from their original site, they take the position at the interstitial space, so density is not changed. But in this case cations and anions are missing, hence we say that density is decreased. Clear? Please listen carefully and follow it. You can follow it if you listen carefully, and if you want to understand it more clearly, then see the video again. It will be more clear. Now the fourth point is, it takes place when the anion size is higher than cation size. Means radius of cation and radius of anion is low, and in this case Schottky defect, the cation and anion size, they are nearly equal, means r plus ratio radius of cation divided by radius of anion, they are near 1. So these type of substances, they show Schottky defect. Now here what happens in Frenkel defect, like charges closeness. How? We have seen that in Frenkel defect, here it is positive charge, here it is positive, so like charges are very close. So like charges closeness, what does it causes? It causes increase in dielectric constant of the substance. But here in Schottky defect, the charges, cations and anions are missing, so the charges are very far from each other. So this equal decrease or no change in dielectric constant of the substance. So these were the difference between the Frenkel defect and Schottky defect, which are present in ionic solids. Now, for example, if we see that examples are taken, then examples of this is ZNS examples, ZNS, AgCl, AgBr, these are the examples, and here examples are examples of the solids which exhibit Schottky defect. They are NaCl, KCl, CsCl and AgBr. You have observed that AgBr, silver bromide, it exhibits both Frenkel defect and Schottky defect. Okay, here you see that NaCl, they are of equal size, nearly equal size, these are equal size, and their radius ratio is nearly 1. But here you see Zn, zinc, sulfur, they are the size of anion and cation, they differ by a large amount. So these solids exhibit Frenkel defect. Now the third type of defects is in metals. One is metal excess defect and one is metal deficiency defects. So let us take a fresh page for defects in metal solids. In metals. See what happens in these are the defect we have read about defects in ionic solids, and now we will read the impurities in ionic or non-ionic solids. This metal defects we shall read after these impurities. Okay, now impurities are both for ionic and non-ionic solids. See, when molten NaCl molten sodium chloride is crystallized, molten NaCl is crystallized in presence of SrCl2, strontium SrCl2, then what happens? Some of the Na plus ions, they are replaced and occupied by Sr2 plus ions. Means 2 sodium ions are missing and 1 Sr2 plus ion is placed, because 2 sodium atoms have 2 positive charge, and this one atom has 2 positive charge, hence their 2 atoms are replaced by 1 atom of Sr2 plus. So cation vacancies are created, and these cation vacancies is equal to number of because 2 sodium atoms are missing and 1 strontium Sr2 plus ion is placed. So this is called impurities and impurity defect. Now we come on to the these all were, see, let me clear you one thing at this stage, that these all are 1, 2 and 4. These are non-stoichiometric defect. Means formula or structure of the solid is not changed, but here it is non-stoichiometric defect is in metals. These were which we have studied so far, that is stoichiometric defect, and now we come on to non-stoichiometric defect, that is metal excess in metals, metal excess defect and metal deficiency defect. These are very interesting defects, and please listen it carefully so that you enjoy the topic and you can learn while enjoying the topic. Now this is metal excess defect. What is this? Due to anion vacancies metal solids, in metal solids, what happens? See, when NaCl solid that is heated in atmosphere of sodium vapors, what happens? See, here these are the sodium chloride crystal. These are the ionic arrangement in the crystal. NaCl, NaCl plus is represented by the Na plus ion and minus is represented for the Cl minus ion. When this is heated in sodium vapors, what happens? The anions sodium, here sodium is reacted with this Cl minus and Cl comes at the surface. Sodium is collected at the surface because NaCl is heated in sodium vapors. Sodium is collected at the surface of the crystal and Cl minus anion, Cl anions, they come at the surface, leaving behind a space. And Na, when combined with Cl ion, it is Na plus plus E minus. They release electron and this electron occupies this vacancy created by the movement of this chlorine ion. And again, you see, at the surface, Na atoms, more of the Na atoms are there. They release one electron to form a sodium ion, and chlorine from this lattice, they come at the surface forming NaCl, and this electron released occupies this place like this. Here what happens? Chlorine is deficient because chlorine has left the site and have come to the surface. So chlorine is deficient. In the process, sodium is in excess. So we say that it is metal excess defect. Metal excess defect. Metal deficient defect we shall study in our just coming video. After this, after metal excess defect, we shall study metal deficiency defect, and these are called E minus electrons which have occupied the lattice sites. They are called F centers. And due to this defect, we observe different colors in the crystals. Like with this metal excess defect in NaCl, sodium chloride, so this sodium chloride attains a yellowish color. Why? Why? This is very important. Because the energy in light, these electrons, they absorb the energy, they absorb the wavelength of the light, and yellow color is not absorbed by these. The other parts of the light is absorbed by these electrons for excitation, and the left part, yellow color, is left, and we see a yellowish color of the sodium chloride. Similarly, if we see lithium chloride, if lithium is in excess by the similar process of defect, metal excess defect, then it is of pink color. And same if KCl, if metal excess defect of potassium is observed, then it is violet in color due to excess of potassium. Here it is pink color due to excess of lithium. Now, one is the example of zinc oxide. Here one defect is found in zinc oxide ZNO when heated. Then it is broken into Zn ion plus 2 of electrons are released. So this is white in color and this is yellow. How? Because Zn2 plus goes to interstitial sites, these Zn2 plus, they are occupy interstitial sites of ZNO crystal, and these electrons are released and they occupy neighboring interstitial site of neighboring crystals. So in the process what happens, this Zn2 plus excess is in excess in the crystal and that make the crystal yellow color. Here excess of cations, so it is a metal excess defect. Now we come to metal deficiency defect. Metal deficiency defect. Many solids are not in stoichiometric compound as shown by their formula. Like FeO is not that one atom of Fe plus one atom of oxygen. This is not the position. Then what is the position? Crystal of FeO, in this Fe2 plus ions are dislocated, and in this place what happens, Fe3 plus ions they replaces these Fe2 plus ion. Means if 3 Fe2 plus ions are lost, then 2 Fe3 plus ions will replace these 3 Fe2 plus ions to maintain the electrical neutrality. Electrical neutral अब भी है ये, because there are 6 charge plus charges, here also it is 6 plus charges, तो electrically neutral substance रहता है ये, it is electrical neutral. But in this process what happens, the metallic part, metallic nature is reduced. Why? Because in place of 3 Fe ions, Fe2 plus ions, only 2 Fe3 plus ions have come to the crystal. So metallic nature is reduced, and this is called metal deficiency defect. See, actually this FeO is the Fe 0.95, not 1. It is 0.95 O. Basically it is ranges from 0.93 to 0.96 depending on the number of defects. So this is the case of metal deficiency defect. So thank you very much for watching the video, and let me again request you to please subscribe to my channel, and if you have liked my video, liked this class, so please show in the comment and also like the video. Thank you very much.